Okay, so this is my first attempt at a video. So you may have seen my post on the League. This topic was suggested by Ostev745. They suggested taking a look at simultaneous equations. Since this is my first video, I'm just going to go over some little basics here, see how it uploads, see what the video is like. It's a little bit difficult to focus the way I've got my camera set up, so I'm going to have to see what that's like in the video. I can't really see if it's focused correctly or not, although it should be reasonably close, certainly close enough to view what I'm writing anyway, and to see what the audio is like as well. Unfortunately, I don't actually have a dedicated microphone, so we're just relying on the audio of my camera, which isn't the best, but you know, it's what we've got to work with. So this question here, now I'm not going to go over any details here. I'm literally just going to go through a couple of examples. I just want to see how this uploads and what it's like. You know, I'll try and make better quality videos in the future as time goes on. But for the time being, I just want to try and push these out as quickly as I can, so that I can help as many people as possible in a short period of time. So this example here is about as simple as simultaneous equations get, really, where you have y equal to something and then y equal to something else. So in this case, it's quite straightforward. You simply say that 3x in this case is equal to 2x plus 1, because if y equals that and y equals that, then these equal each other. Okay, so in this case 3x plus 3x equals 2x plus 1. So when you've got this here, it's best to subtract 2x off both sides. Here that will leave you with 3x minus 2x is x. Here 2x minus 2x is nothing, of course, and you'll just have 1. Now you can, some people aren't very confident with deciding, you know, what way you're moving things and such. So with this example here, if you decided to subtract 3x off both sides, it would still work. This side here would be 3x minus 3x, which is 0. This side would be 2x minus 3x, which is minus x, and then the plus 1. And then once you're at this stage, then you can add x to both sides, and you'll have x equals 1. Or alternatively, you could subtract 1 off both sides there. If you were to do that, then you'd have negative 1 on this side. Here you'll just have negative x, and obviously we don't want negative x, we just want x, so times both of these then by minus 1, or divide by minus 1, it's the same thing really. Well, it's not the same thing, but it gives you the same result. So in this case, x would be equal to 1. Now once you have one solution there, so you know, in an ideal world you would have stopped there, got x equals 1, that's good. You then put this back into one of your equations. So here I'm just going to put it into this first one. So y equals 3 lots of 1, 3x. So y is equal to 3. So then we have our result. Okay, 1, 3. So what this means graphically, if you were to draw these two lines, is that these two straight lines intersect at that point. Now, a good thing to do is to actually put this into this equation now. So y is equal to 2 lots of 1 plus 1. So that's 2 plus 1 is 3. So y there is 3. Well, we had 3 before, so yeah, so that's right. If there we worked out, say, 4, let's say, obviously, you know, that would then be wrong. That tells us some information there, and the information that it tells us is that we've made a mistake somewhere. It doesn't say where we've made the mistake, but it lets you know that you've made a mistake. Okay, so just a little bit of exam technique for you there. So let's take a look at another question a little bit like this, but slightly more complicated. So question 2. So we have y is equal to 2x plus 6 and y is equal to 3 subtract 4x. Okay, so the same thing here. You've got y equals something, so you simply say that that equals that. 2x plus 6 is equal to 3 subtract 4x. Same thing, I always deal with x first. You know, this side here is positive x, this side is negative, so it makes sense to add 4x to both sides so that so that the x's stay positive. So in this case, 2x plus 4x is 6x plus 6, and then the right hand side will just be equal to 3. And then what we want to do then is we want to get the x term on its own, so to do that we need to subtract 6. So we'll have 6x is equal to negative 3, and then to solve this then we just divide both sides by 6, so x is equal to negative 3 over 6. Now a lot of people here would stop, and that's not the thing that you should be doing. You need to, whenever you calculate a fraction, always think, you know, is it simplified? You know, do I need to simplify it? That's what you should always be asking yourself. And in this case, that would be negative 1/2. 1 3 gives you 3, 2 3s gives you 6. And then once you've got that, then we then put that into our first equation to calculate the y value. So that's 2 lots of our x value here. 2 multiplied by negative 1/2. Well, first of all, it's going to be a negative. 2 times 1/2 is just 1. And then we've got plus 6. 6 subtract 1 is 5. So we now have our coordinate of intersection. Negative 1/2 of 5. And what you should do is get into the habit of then checking this answer with this equation up here. So y is equal, and remember here we're looking for a value of y here of 5. If we don't get 5, then we've made a mistake somewhere. We need to go back and check. So 3 subtract 4 lots of x. And that's 3 minus 4 times minus 1/2 will give you a plus, not a minus. 4 times 1/2 is 2. In that case that's 5. That's what we were expecting. Yeah, that's good. So that is almost certainly the correct answer. Right there you have 2 examples of how you can solve a simple simultaneous equation. Okay, 2 straight line examples. So these are all linear simultaneous equations. And I think that's where I'm going to end this video. Hopefully it turns out okay. If it does, I'll upload it to YouTube, and later on today I'll start uploading some more. I'll upload some more examples of simultaneous equations that are more complicated than this, and I will also probably look at solving these graphically as well, so that you can get a deeper understanding of what it is that you're doing here. But yeah, thank you very much for watching.